space propulsion. This is just going to be a little bit of an intro to space propulsion, not a whole lot to write down here because you're going to do the research on your own. So let's get started. Just a quick review of Newton's laws of motion. There's the law of inertia, F equals ma, and Newton's third law, which is for every action force, there's an equal and opposite reaction force. So when we're talking about space propulsion, things that you need to know, you need to keep in mind with space propulsion, is that space is frictionless. Small forces can result in great movement. If you vent gas from a spacecraft, you can cause spinning or undesired movement. You can also cause desired movement if you vent gas in specific ways. Spacecraft frequently adjust direction with small pulses. That would be the venting gas in a desired place, and each pulse uses fuel. Sometimes that fuel is just in the form of compressed gases, and sometimes it's actually something that's combusting. Usually when you're in space, though, it's just a compressed gas. So I'm just going to talk about a few, in very general terms, just give you kind of an idea, and then you're going to do some research with a partner on your own. So this is an example of an ion thrust. You can see the nozzle right here. Some of you may choose to do this one, but this one is just electric energy. This is a type of electric propulsion, and it expels ions from the nozzle. It's an efficient use of fuel and electrical power, and I'm not actually going to go into how it works here because someone in class is going to do that and explain that to us. Last, it allows modern spacecraft to travel farther, faster, and cheaper than any other propulsion technology currently available because it's small pulses of energy. So this might be how it looks. Hall thruster is another example of one. It uses an electric field to accelerate ions out, and if it's accelerating ions, which are just a small, incredibly small mass, but if you do enough of them at really high velocity, then you're going to start to getting pushed in the opposite direction. That's Newton's third law. And as long as you push a force in one way, it's going to cause a mass to accelerate in the other way, and that's Newton's second law. So solar sail is another example, and I'm sure someone will choose this one. It's very cool. It uses the sun's energy to enable travel, and it does so in a way that uses solar particles and that it bounces off of them or chooses not to bounce off of them. So once someone talks about this in class, you'll learn more about that one. And that is really all that I'm going to talk about. So that's just a brief introduction on some of the examples that you might learn about when we do our group presentations.